let's pick back up in lesson 6-3. So your job will be to finish the homework for tomorrow. Okay, make sure you're writing in them. Okay, so yesterday we started the backside. We were multiplying binomials, which means we were foiling, right? We foiled these first two. I can tell you if you're someone that you worked out the third and you want to know if your answer is the right or not, you should have gotten 46 plus 16 square root of 5. So I'm not going to take the time to work through that right now because I want to make sure we get through everything I want to get through today. And notice, what are we still doing on my next set of examples? Foiling, right? It's still a binomial times a binomial, so we are still foiling. That has not changed. So, did I give you guys enough time? Did some of you get done with it? Okay, work with me here. What's first? 5 times 5, which is 25. O, outsides. Yeah, 5 times square root of 7 is 5 square root of 7, so plus 5 square root of 7. Insides. Yeah, it's negative square root of 7 times positive 5, so that does make it minus 5 square root of 7. And last? Okay, so negative square root of 7 times positive square root of 7 is, one way to say is negative square root of 49. Okay, what thoughts you got for me?
You cancel out the...
Yeah, what do you guys notice about the middle two terms here? It's 5 radical 7 minus 5 radical 7, so those will cancel. What else you got?
You drop down to 25.
Okay, 25 is just 25. Yeah. What is the square root of 49? 7, so that's going to drop down as a minus 7. 25 minus 7 is 18. Notice, the official title of this line of problems is multiplying conjugates. Do you guys remember what conjugates are? Conjugates are where the first and second piece are the same, but the sign in the middle is different. Not both signs, just the one sign is different. And so, when you multiply conjugates, the numbers are the same, it's just that middle sign. It's designed so that the middle pieces will cancel out. Okay, so those middle pieces canceled out. The nice part is that it caused my square roots to drop out as well. Okay, so that is the design of conjugates. If your middle pieces don't cancel out, you made a mistake. And I'm not sure I'm going to do all of these examples, but let's go ahead and do B to practice. Because I'm more concerned about getting to the bottom line of examples there. Okay, have you guys done B? Working on it? What's first? 6 times 6? 36. Outsides? 6 square root of 12. So that is a plus 6 square root of 12. Insides? Okay. Minus 6 square root of 12. Okay, minus square root of 144. What was your question, Keith?
Instead of doing all that, since you know they're going to end up canceling out and your knowledge is going to end up being itself again, you should take 6 times 6 minus 12. That's what's going to end up happening.
You can, just be careful. Okay, so his question is, are there some steps we could skip? Possibly. You have to be careful with it, though. Okay, that's my only warning. For instance, if you realize going in right here, these are conjugates. What's going to happen because they are conjugates? Those middle terms are going to cancel out. I would at least kind of multiply them in your head or just do a double check in your head. Okay? And then the other thing, some of you are hitting that point where you don't want to do 12 times 12 and get 144. What is the square root of 12 times square root of 12? It's just 12. When you multiply a square root by itself, it is just 12. So if you want to go ahead and jump to that step, that's fine. If you don't jump to the step, that's fine as well. Okay, so we end up with 36 minus 12, which is 24. Okay. I'm going to skip C if you don't mind. If you happen to work C, I will tell you your answer is 1. Okay? Or if you want to work C at some point and check it out, I'll tell you the answer. I am concerned that we need to know how to do the bottom row, because this all leads up to the bottom row. Okay? We've been practicing multiplying, specifically multiplying conjugates in that past row. Example 6, officially this is division, because we have a fraction, right? And if you remember, the rule with fractions is we're not allowed to leave a radical in the denominator. All of these right now have radicals in the denominator. So I can't leave it like that. In the last lesson, lesson 6.2, if there was a single radical in the denominator with nothing else, like no other adding, subtracting, we just, in order to rationalize, we had to multiply by that radical, right? By that square root. These are plus or minus problems. Do you know why we were practicing conjugates? Do you remember how to rationalize when there's two terms? You're going to have to multiply by the conjugate. Okay, that's what this is designed to do. When you have two things being added or subtracted in the denominator, you multiply by the conjugate. And that's specifically the conjugate of the denominator. So what I wrote over there is multiply by the conjugate of the denominator. So, look at example A. It's 3 square root of 2 over square root of 5 minus square root of 2. How am I going to rationalize? What is the conjugate of square root of 5 minus square root of 2? Not quite. You only change the middle sign. So if this is square root of 5 minus square root of 2, the conjugate is square root of 5 plus square root of 2. You only change one sign. Generally speaking, it's the middle sign. Technically, if we change just the front sign instead, that would work as well. Now, you guys know what I'm going to say. Whatever you do to the denominator, you got to do to the numerator. So we're going to be multiplying the numerator by square root of 5 plus square root of 2. Okay, let me zoom in here and let's get to multiplying. How do I multiply on top? I have a 3 square root of 2, which is just one term, and it has to be multiplied by these, so we're essentially going to distribute. There you go, there's the word I'm looking for. So we're distributing on top. So what is 3 square root of 2 times square root of 5? Remember, when you multiply, keep outside numbers outside, multiply inside numbers. So 3 square root of 10. Plus 3 square root of 2 times square root of 2. Three square root of 4. What do I have to do in the denominator? Officially, it's FOIL. Some of you might be able to skip some pieces if you're careful, but officially it is FOIL. So first, square root of 5 times square root of 5. Square root of 25. Square root of 5 times square root of 2. Plus square root of 10. Insides, negative square root of 2 times square root of 5. Negative square root of 10. And last, negative square root of 2 times positive square root of 2. Minus square root of 4. Okay. What are some pieces you see? Some things that can happen here. In the denominator, square root of 10 minus square root of 10, cancel. That's the design, right? If your middle terms don't cancel in the denominator, what did you do wrong?
You did something wrong.
Okay, that's multiplying conjugates. What else do you guys see?
25 quarters.
Okay. Square root of 25 is going to become 5. Square root of 4 is going to become 2, and that also includes square root of 4 on top is also going to become 2. If you went ahead and wrote those as 5s and 2s when you did it, more power to you. That's perfectly fine. So let's clean up and see what we're at. My numerator, I still have 3 square root of 10 plus, what does that 3 square root of 4 become now? 3 times 2, which is 6. My denominator, officially, what are the pieces I have left? 5 minus 2, which, if you go ahead and write, what is 5 minus 2? 3. You're welcome to go ahead and write that. So I have 3 square root of 10 plus 6 all over 3. Okay. In certain problems, you're going to be done right here. You're going to end up having to leave it in this form because you can go no farther. In this particular problem, my denominator is a 3. And what do you notice? 3 divides into 6, and 3 divides into the coefficient that's in front of the radical. 3 divides by 3. It doesn't touch what's inside the radical, but it has to be able to divide what's outside the radical. So this is going to become 3 square root of 10 divided by 3. The 3's will cancel, and I'll have square root of 10 plus 6 divided by 3 is 2. I was waiting for someone to correct you, but you got your own correction there. So square root of 10 plus 2, or 2 plus square root of 10. Make sure when if you're writing this by hand that you're careful that that plus 2 is not under the radical. Or even if you're typing it for that matter, right? Okay. I don't think I'm going to necessarily do both of these unless we just really feel like we want to.
No, we're good.
I'm going to skip to C. I'm going to skip to C. I will write the B answer up here in case anyone's practicing with it or already started it and mad that I'm skipping it. So, for your information, the answer to B is negative square root of 21 minus square root of 35. Let's jump over to C. C is 4x over 3 minus the square root of 6. What do? I can't have a radical in the denominator. Multiply by the conjugate, which is 3 plus square root of 6. And of course, what I do in the denominator, I do in the numerator. Okay. And it's possible some in homework you see you might have to FOIL on top. This one again, you're not foiling on top, you are just distributing. So what is 4x times 3? 12x plus 4x times square root of 6. 4x square root of 6. Denominator, got to FOIL. So first, 3 times 3 is 9. Outsides, 3 times square root of 6, 3 square root of 6. Insides, negative square root of 6 times 3, minus 3 square root of 6. And last, negative square root of 6 times positive square root of 6. Minus square root of 36. Okay, what kind of things do you guys see? Do my conjugates work like they're supposed to?
Yep.
Yeah, 3 square root of 6 minus 3 square root of 6 cancels. In the denominator, I'm also going to be able to do square root of 36 is 6, so I'm going to be able to do 9 minus 6, which is 3. So I have 12x plus 4x square root of 6 all over 3. Thoughts?
Wouldn't you just combine 12x and 4x? And that would be it.
What's attached to the 4x though?
Yeah, I mean, so you just leave the 12.
Okay, so on top, I cannot add 12x and 4x because it's 12x and it's 4x radical 6. So since they don't both have that radical or square root of 6 there, I can't add on top. As we look at that 3 could divide into 12x. However, it doesn't divide into 4x. Okay? So, and of course it can't go into square root of 6 because that's under square root. You could split it up into 2 pieces, and that second piece would just still have to be a fraction. One of the options I actually have written in my notes is leaving it just like this. The other option, and I just kind of want to introduce it so you're familiar, that denominator of 3. If I pull that denominator of 3 out front, it's a 1/3. And so you might see this written as a 1/3 times the 12x plus 4x square root of 6. I am perfectly fine with you leaving it in my first option. That's perfectly fine to me. But I want you to realize that a denominator of 3, if you pull that out front, like kind of like a GCF or whatever, it's like a 1/3. And then you just have the rest. Yes?
So why can't we divide the 12x by 3?
You could, but then you'd have to split it up into 2 fractions. And at that point, like if we do 12x divided by 3, that is 4x. And then the rest of it would still have to be 4x square root of 6 all over 3. Because the 3 has to go into both pieces. And that right there, I mean, it's equivalent. I wouldn't count that wrong. But those look a little bit nicer. Okay, your job is to finish lesson 6-3. You have a little bit of time right now that you can use.